All right, so today we're going to talk about exponential models again. If we recall, last week we took, we started with the doubling equation. We started with a penny, we're going to call that 1, that went 2, then 4, then 8, then 16, and so on. And then we put a second equation that showed us how much we were changing. So this first one we added 1, then we added 2, then we added 4, then we added 8, then we added 16. This was day 0, 1, 2, 3, 4, and so on. So we just added every time, right? This is how much we have. This is how much we add. Okay. What we're going to do now is we're going to think about how the amount that we add for an exponential model can be thought of as a multiple of how much we have. Okay? All right, so we're going to go over here, we're going to go to multiple. All right? So our multiple in this case is 1. 2 times 1 gives us 2, right? Our multiple is 1. Okay. So what does this help for us? Knowing the multiple. Well, if we remember, we went ahead and we thought about this as an amount plus the amount we add, right? Or in other words, we did 1 plus the amount that we added. We're going to call that the rate, R. Okay? And that was the thing that we wound up multiplying over and over and over and over. In this case, the multiple was 1. So 1 plus 1. This would be powers of 2. And you probably already knew that. It's 1 squared is 2. 2 squared is 4, 4 squared is 8, 1 times 2 times 2 times 2 powered to 2, not multiple, not iterative squaring, but multiplying by 2. Anyway, so this is the thing that's getting multiplied to the power of t, okay? And this right here, this expression would give us our value over time, all right? Where t is the number of days, and then r is our amount that we're adding. There's one last piece that we need to take into consideration. If instead of starting with just 1, we had started with, okay, stole my eraser. Anyway, let's suppose instead of starting with just 1, we had started with 3, okay? We're going to start with 3 now. So on day 0, we have 3. On day 1, we're going to double that 3, so we've got 6. On day 2, we're going to double that 6, so we have 12. All right? Just like that, just the same doubling problem like we had over here. We're just starting with a different number. Now, what I want you guys to notice is if we divide off that initial value, we're going to look at, so this is what we have. And this one we're going to divide by 3. All right, so 3 divided by 3, of course, is 1. 6 divided by 3 is 2. 12 divided by 3 is 4. And let's go on. 3, 4, we'll go to the 5th day. Okay, so 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. Now let's go ahead, we're going to divide by 3 each time. So dividing 24 by 3, we get 8. 48 divided by 3 gives us 16. And then this one gives us 32. So what we notice is when we divide by 3, we get the same value as when we started with 1. In other words, in each case, our expression here is our expression here multiplied by 3, right? If we divided by 3 to get from here to here, we multiplied it by 3 to get from here to here. So we can say that this would be 3 times 1 plus 1. Okay? This 3 times represents what we call our principal value. That is how much did we have when we started. Okay? So we've got a rate, we've got a time, and we've got a principal value. Okay? This right here, this expression, is the general expression for any economic growth or decay. All right, now I said both growth and decay can be expressed like this. Let's do a quick example. let's suppose I've got $1,000. $1,000. That is what I start with. That would be my principal value, okay? And that $1,000, I'm gonna get, let's say, 1% interest every month on that $1,000. And that's my equation, that's my problem. I'm gonna get 1% interest on $1,000, and I wanna know when is it gonna be $2,000. Okay, so the key numbers to remember, this is my principal. Okay, and then I've got 1%. That's my rate. And then the last piece of information is $2,000, and that's my goal. That's my goal. Notice, goal isn't one of the things on here. Okay, so in order to figure out what my goal is going to be, how much time it's going to take to get to my goal, I've got to change this expression into an equation. But let's combine that together. So in my expression here, the things I know my principal, so I'm going to put that there, that's 1,000. I know my rate is 1%, so that's 1 plus 1%. I don't know my time, so we're going to go ahead and put t up here. And remember, we said it was 1% per month, so we're going to say t is in months. We're going to write that down. Okay, we're going to write down that t is in months so that we remember. Because we might get to the very end and say, okay, t is 24. What does that mean? Is it 24 days, years, weeks, months? We want to write it down so we remember. Okay, so here's the expression. This expression tells me how much money I've got at any point in time. Well, what I want to know is, what's my goal? When do I get to my goal? So we need to create an equation. We're going to say 2,000 is equal to 1,000 times 1 plus 1% to the power of t, where t is in months. Okay, now we can solve for t. Okay, let's go ahead and solve for t. All right, so if I've got 1,000 times an exponential is equal to something. If we remember from our exponential unit, when we were solving, the first thing we need to do is divide that constant out. And of course, whatever we do to one side, we have to do to the other. Okay, so now that would give us 2 equals 1.01. I just added that together to the power of t. Okay, now I'm trying to solve for t. T's in the exponent. In order to undo an exponent as a variable, we need to take the logarithm of both sides. So what we're going to do is we're going to go log 2 is equal to log 1.01 to the power of t. Then we're going to apply the power rule. T comes out like that. We get log 2 is equal to t log 1.01. Now we just solve for t. So we're going to divide by log 1.01. Remember, that's just a number. Whatever we do to one side, we've got to do the other. Divide by log 1.01. So if we pull this up here, we get t is equal to log of 2 divided by log of 1.01. Or, if we remember our change of base, that's going to be t equals log base 1.01 of 2. And that's our final answer here. Now, I'm going to do a quick substitution so I can show you how we can get our answer just in terms of our initial values. So instead of 2, we know that we got 2 from 2,000 over 1,000. I'll leave that here. But we're going to say, okay, so t is equal to log base 1.01 of 2,000 over 1,000. That's our goal divided by our principal. So we have goal divided by principal. And then 1.01, that was 1 plus our rate. So we're going to replace that as 1 plus our rate. So what that means is, if we want to know how much time it's going to take to get to any value, we can jump straight to here. Right? So this might be something you want to put down in your notes. Now today in class we're going to go over some example problems of doing this, but the idea is it always is going to follow this formula, whether it's growth or decay. Note, if this had been decay, our rate would be negative, okay, which would mean that our would be 1 plus a negative number, so it's 1 minus, essentially. Right? But otherwise, that's it. This expression right here, or if we want an equation, we could call it y is equal to. This equation is the only equation that matters for this unit. I'll say that again. This equation right here is the only equation that matters for this unit. So if you can handle this equation, you can do every problem that you're going to see in this unit. All the problems are basically reading some paragraph and pulling from that paragraph a principle, a rate, a time, and a goal. And one of those 4 things is going to be unknown. And we just solve for it. If it is time that's unknown, we know how to solve for it. If it's something else that's unknown, we should be able to solve for those too, just by evaluating what we do know and moving on. Okay, go ahead and be ready for some bell work, and I will see you in class.